So previously we had been solving these quadratic equations by factoring. So that's what we were practicing earlier, where you guys factored it and then you set them equal to 0 and you set each piece equal to 0 and then you solved them for your x. We can also do graphing and find solutions as well. So remember when we first talked about this, that when I said you're looking for the solutions of a quadratic, you're trying to figure out where does that parabola cross the x-axis, because those are the solutions that we're looking at. So this chart kind of summarizes the 3 different cases that you can have when it comes to finding solutions for quadratics. It can either have one real solution, so that's this first case. That's when the parabola hits the x-axis at one point. And so that one point would be the vertex. Because if you guys notice, that point's like the middle of the graph. So that's going to be the one vertex point. And if it's sitting like on the x-axis like that, there's only one solution then to that equation. The second scenario is the one in the middle, where it crosses 2 times. There's the first one, and there's the second one. So that has 2 solutions. The third case is if that graph is never going to cross the x-axis. So if it starts too far above, or if it was flipped upside down and it started too far below, and it would never cross, because if it's like this one opening up, these arrows are going to go up forever. They're never going to eventually turn and come back down. So it doesn't ever cross the x-axis, which means that there's no real solution. There are still solutions to it, but notice how it says no real solution. We have something called imaginary numbers out there, which we'll get to eventually in this chapter, but we're not dealing with that today. So just know that if it was graphed, and if it's written like that, there are solutions out there, but we can't find them on the graph because they're not considered to be real. The main situations that you guys are going to see are the first 2. You're going to see the ones where the graph actually hits the x-axis and there's one solution, or you're going to see it pass twice and there's going to be 2 solutions. So let's go over an example of how do you actually do this using a graph. So some of this you guys have already done. Previously in like section 1, we were graphing quadratic equations. We were using tables to help us do that. So to find kind of your starting point for your table, because you don't want to just be throwing in random numbers. I mean, you could, but the problem with that is that you don't know where the vertex is right away. So if you're just throwing in random numbers, you might only see one side of the graph, and you need to see both sides in order to see where it passes the x-axis at. So we have to start by finding our vertex. So you use that equation, negative b over 2a again. So we've seen this before. Remember from your quadratic equation up here, a is always the number in front of the x squared, which this one has a 1, so a is equal to 1 for this equation. B is the term in front of x, which would be negative 6. And c is the number at the end, which would be 8. So when I go to plug this into my equation, I'm doing negative b, so it's going to be negative 6, over 2 times a, or 2 times 1. So negative 6, double negatives makes it become positive, so we have positive 6 now on top, over 2. 6 divided by 2 would be 3. So if you remember when we were talking about this point, that's like the axis of symmetry, which is the x-coordinate for your vertex. So what we did from here is we took 3 and we plugged it into this equation up above. So the equation that you started with, in order to help you find the y-coordinate. So I'm going to take 3 squared minus 6 times 3 plus 8. Make sure as you're plugging it in that you guys are putting parentheses like I have written up there. See how I have parentheses around my 3's? Make sure that you guys, if you're typing it in your calculator, that you're using parentheses, especially if you're throwing in a negative number. Because if you square a negative number, it should be positive. If you don't put it in parentheses on your calculator, you're going to get a negative number to come out because your calculator doesn't know that it's the negative squared. So you got to make sure that you enter it like I have it written here. So if you do that, it's like 9 minus 18 plus 8. You end up with a negative 1. So the vertex is going to be 3, negative 1. Another point that we should be able to pull from the equation is the y-intercept. So remember, the y-intercept comes from the c, which this one, c, is 8. And when we wrote that as a coordinate, x is always 0. And then it's your c, which is 8. So the y-intercept would be 0, 8. So what I can do to kind of help me find other points and find the solutions that I'm looking for, now that I kind of have an idea of what my vertex is and what my y-intercept is, I can create a table. We put the vertex in the middle. So 3, -1 goes in the middle there. And then we want to pick a couple points above and below 3. So like 1 and 2, 4 and 5. So either plug those back in like we've done up above with the vertex point. So plug it in on your calculator using parentheses, or use the yellow calculator. Use that table function that we've talked about in the past to type in the equation and then just look at your table. If you put in 1, you should get 3. If you put in 2, you should get a 0. And then 4 should be a 0, 5 should be a 3. So remember, there should be kind of like that repeating pattern with those y coordinates. Now what I'm going to do is circle 2 points, 2, 0, and 4, 0. These points are important because the y is at a 0, which means that they're on the x-axis, so those are my solutions. Okay, another word that they might use for that would be zeros. So they might ask, like in a problem, if you're using a quadratic, they might say find the solutions, or they might say find the zeros. They're talking about the same thing here. So these would also be known as zeros. All right, so now I'm just going to go ahead and graph this now. So I've got 1, 3, 2, 0. See how that one's sitting on the x-axis right there? So that's where it's going to cross. That's why it's a solution. Vertex is at 3, -1. 4, 0. So there's the other solution because it's sitting on the x-axis. And then I have 5, 3. And if I wanted to, if I had space, you guys could do the 0, 8 point. I don't know if I have room on mine here. It'd be way up here. And then you could reflect that point too if you really wanted to add some more points there. And then draw that graph in. Okay, so these points, like we said, there and there, those are your zeros. And so those are at 2, so when x is 2, and when x is 4. So what I could have done to check this one would have probably been pretty easy for me to factor. Like if I go back up and look at the problem. So if I look at the equation that they gave me, x squared minus 6x plus 8. If I wanted to factor that, two numbers that multiply to 8 and add to a -6 would be -4 and -2. So I would do x minus 4, x minus 2 in my parentheses. Then if I set those equal to 0, x minus 4 equals 0, x minus 2 equals 0, I would add 4, add 2. So I get +2 and +4, which is what I have here on the graph. So it kind of all ties together. You could factor it to find those solutions as well. There are going to be some cases, though, where that factoring doesn't work as nicely. And so sometimes it's better to graph. But that would be a way, if you could factor it, you could easily check your answers that way. So I want you guys to turn the page over, and I'm going to give you a couple minutes. I want you to try this one. So do those same steps that I was doing. Find your vertex, use that -b/2a, make a table, try to find your zeros. All right, let's go over this one. It looked like a lot of you had a good start on it. So you guys started with your negative b over 2a. What number is your b? Good, 4, and a is a 1. So you end up with negative 4 over 2, which would be negative 2. Then if you guys take that number and you plug it in there, or if you just typed it into your calculator, or you used, like if you have one of those yellow ones and you're just using the table function, it makes it really easy for you. You just take that negative 2 squared plus 4 times negative 2 minus 5. We should have gotten negative 9. So the vertex is at negative 2, negative 9. If you're not getting negative 9 when you plug it in, 1, make sure that you're using parentheses. Okay, that's a huge mistake that I see happen all the time, is that we skip out on the parentheses and then your calculator is not giving you the right answer. So you got to be really careful about that. All right, so what's the y-intercept point going to be? What's your c value for this? Good, 0, negative 5. So c is negative 5, so we write the y-intercept as 0, negative 5. Now, if we made a chart for this one, which you're going to want to do because you're trying to find the zeros, and right now I don't have the zeros on my graph. So again, I put that negative 2, negative 9 in the middle. That's kind of like a good starting point. Then you want to pick some numbers above and below that. So like below, or like closer to 0 would be negative 1 and 0, and then above it would be, or less than negative 2 would be negative 3, negative 4. If I do that for negative 4, I'm getting negative 5. For negative 3, I get negative 8. Negative 1, I also get negative 8, and 0, I get negative 5. So I haven't found my zeros yet, because I don't see any zeros showing up in the y column. So I need to add a couple more numbers. If I add a positive 1, then I should get a 0. So where should the other 0 be on the other side of the graph? If you follow the pattern of the chart, if this is one of them's at 1, 0, where should the other one be at? Negative 5, 0. Good. So I'm going to squeeze it in up here. Negative 5, 0. And then we should have graphed it. So 1, 2, 3, 4, 5. To the right, or to the left, there's 1, 0. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, negative 9. And then those other points are reflecting. So remember, with these parabolas, when you're graphing them, they should be symmetric on both sides. They should not, like one of them should not be crazy off to one direction and the other one's doing something completely different. They should look symmetrical, even on both sides there. So the zeros for this one would be at negative 5 when x is equal to negative 5 and when x is equal to positive 1. So those would be your solutions, or your zeros there. Okay? All right, we're going to finish up today with just some extra practice of those factoring problems that we've seen. So we're still finding the zeros, we're finding the solutions, but we're going back to factoring. So if you guys take a look at this first one, x squared plus 4x. What's something that I could take out of both terms? X. What's left if I take out an x? Good, x plus 4. We're going to set it equal to 0 so that we can actually find the zeros here. So take x and set that equal to 0, and then x plus 4 and set that equal to 0. So when you set x equal to 0, there's one of your answers. X plus 4 equals 0, we subtract 4. So we get negative 4. Okay, you guys do the next one. So what are two numbers for number 2 that would multiply to 6 and add to a negative 7? Good, so negative 6 times negative 1 is positive 6. And if I add negative 6 and negative 1, I get negative 7. So to factor it, should have said x minus 6, x minus 1 equals 0. So what do we get for solutions for this one? If you set those each equal to 0, what are you going to get for final answers? Good, 6 and 1. Okay, now the next couple, they're those longer factoring problems. So we'll do number 3 together, and then you guys will try number 4. So remember, the first 2 is your A, negative 5 is your B, the last 2 is your C. So you need those because we have to do our A times C here. So 2 times 2, which would be 4. The B term is at negative 5. So I need to find two numbers that multiply to 4. They have to add to a negative 5. What two numbers are going to do that? Good. So just like the last one, it's the number times 1, and they both have to be negative. That way when I add them, I get negative 5. So remember for these, because we can't just drop them into parentheses because we have a 2x squared, we've figured out how to split that. We need to rewrite this. So you leave the 2x squared as is, and the plus 2 at the very end. We're going to set this equal to 0 because we're trying to solve it. We're going to rewrite the middle terms now. So it says like minus 4x and then minus 1x. Or you can just say minus x. You don't have to put the 1 in front. Then we group the first 2 terms and the second 2 terms, pulling that negative in with the x. So looking at my first grouping, 2x squared and then the minus 4x, what can I take out? 2x. And what would be left if I take out 2x? X minus 2. Now, what do I need to take out of the second set so that I get x minus 2? Good, negative 1. So I'm gonna write that in, minus 1, instead of just a minus sign. So then we take 2x and the minus 1. Those get put into a set of parentheses. And then x minus 2 gets put into another set of parentheses. This is equal to 0, so now we're setting them equal to 0 here. So 2x minus 1 equals 0, x minus 2 equals 0. So I'm going to add 1. So I get 2x equals 1, divide by 2. So one answer is going to be a half. For the other one, I just add 2, and I get x equals 2. For the last one here, before you guys jump to doing your A times C, can you guys take a look at those numbers, 2, 18, and 28? Is there anything that I could take out to start? I could take out the 2, can't I? Because they're all even. So let's do that and see what happens. Let's take a 2 out. If I take a 2 out, I'm going to be left with x squared plus what? 9x plus 14. And I'm going to go ahead and write equals 0. Now look at what's inside the parentheses. X squared plus 9x plus 14. That should be easier for us to factor now, because it's going to be able to have an x in each. And then what you're looking for, like if you create your chart, is you're looking for two numbers now to multiply to 14 and add to a 9. So if you can pull something out like that to make it an easier factoring problem for you, I would do that. Okay, what two numbers do that? What two numbers multiply to 14, add to 9? 7 and 2. So we're going to have x plus 7, x plus 2. We set that equal to 0. Now with that 2 sitting out front, when you go to try to set that equal to 0, 2 is not equal to 0. That's not a true statement. You can just kind of scratch that one and not worry about solving it. It's not going to affect this problem at all. But then I do my x plus 7, I set that equal to 0. And then my x plus 2 and set that equal to 0. So what do I get for solutions here? Good. -7, -2.